Alright, the ad is done, time to start a new hard game. Only 67.5, whatever. Alright, so when I play medium I don't usually use notes, but when I play hard I have to use notes. So I'll try to just think out loud what I'm doing. So first off, I am intrigued by this line because you have a bunch of stuff in a row, so let's see if we can do something here. Okay, so what I'm looking for, my strategy is to look for any place inside of a box where I can put a number one of two places. So in this example, here we have two sevens here, so we know that the third 7 has to be in one of those two places. So I put a 7 there and a 7 there. If there's only one option, of course I put it in at once, and if it's 3 or more, I don't bother to make a note of it until at the very end, if I get really stuck at some point or something like this. But for now, only putting notes when there are two options is good enough, and you will see in a bit why I do this. Okay, continuing. So 7, 7, 7. So here, for instance, I know that there must be a 7 in one of those places, but I don't bother making a note of it because that's 3 options instead of 2. And then I like to sometimes, if I'm stuck or whatever, just work my way up from 1 to 9. So for the 1 here, I don't immediately see any 2 or less option thingies. Continuing with 2, a little bit more 2s here. Oh, see? So here's 2 and 2, so it's in the middle row here, but this 2 restricts it to those 2. So then I put the notes there. Okay. Any more 2s? Oh, similarly up here, 2, 2, and 2 makes these 2 the possible options. And similarly here, there are 2 and 2, not there, sorry, there, because of this one. And to the top here, there are these 4 options, so I'm not going to make a note of that yet. Okay. Now, one interesting thing we can see here is that I put these 2 here on as 2 options, so they have to be on a line. So that means that this is not an option anymore, because the 2 is either here or here, so it can't be there. Alright, cool. So we already made progress. Moving on to 3. Yes, this one and this one and this one makes these 2 the only options in that box. Sorry, 3, 3. And similarly, these 2 going to the left means that these 2 are the only options. So let's put those there. Okay, moving on to 4. 4, 4. Okay, here we have another situation where those 2 are the only options. 4 and 4. Moving on to 5. Oh, yes. This and this plus this and this means that this is the only option in the top left box. So I work in sort of like triangulation, right? 1, 2, 3. 1, 2, 3. So that's a 5. Going downwards, well, this one and this one means that those are the only 2 options, so that's nice. 5 and 5. And once again we have that they're on a line, so they can help triangulate the third box. So it means that it must be in the top row, and this one restricts it further, so we can put a 5 and a 5 here. Okay, that's progress. the 6. Oh, this is nice, yes. So we have 6 and 6, so it must be in the middle, and 6 and 6, so it must be in the middle. So then we know that this one is a 6, and from our earlier notes we now see that there's only one option for 3, so we can put a 3 there. Progress. Okay, now we can look at this 3 again. Now we have a new triangulation up here, and there's only 2 options of 3, so we can put 3 and 3. Okay, so what were we working on? We were working on the 6th one. Oh, here we have this one, and this one, and this one, means that only these 2 are options. 6 and 6. And for the top one it's all 4, but I'm not gonna bother to make a note of that. Oh, here we have this one means that this one is the only option. And now we have a 4, which can only be one place. And a 2, which can only be one place. So now we have some new information. Let's see if it gave us something. For a 4, we see that now these are the only options here. That's nice. And for a 2, yes, we get that these are the only options over there, and this one restricts one of them even further, so we have a 2 there. Okay. Oh, something happened down here now. We see that one of our notes went away when I put a 2 in there, so now 2 only has one option, which is over here. We can double check that this checks out by seeing that the triangulation gives us this one. Nice work, which means an add. I fail 369 times. I'll get some water while this ad is playing. Okay, where were we? This was... I think we're done with the 6 ones for now. Oh well, we have some new information up here. So these 2 means that it has to be one of these places, and this one means it has to be one of these 2 places. So that's worth taking a note of, 6 and 6. Alright, moving on to 7. 7, 7, oh, nice. We immediately see that these 2 means that 7 must go here. And 7, 7, this one is already in place. 7 here and 7 here restricts it to be one of these 2 places, so that's worth taking a note of. And yeah, we have that it's one of these 3, but I'm not bothering making a note of that. Similarly to the top right and top left, there's not much to note. Okay, moving on to 8. We immediately see that for this one, 8 is only possible down here. So we make a note of that. And what else? Oh, because 8 is only down here, we can use it as part of triangulation to see it must be in the middle here, and the 8 up here restricts it further, so we only have 2 options. Now we come to a situation which I have been wanting to talk about, but I wanted to wait until it happened. So we have a 5-8 and a 5-8. This is called a pair, and the pairs are very useful. They are the main tool to solve harder Sudokus. Because what we now know is that there is either a 5 or an 8 in those 2 boxes, meaning that there can't be any other number than 5 or 8 in those boxes. And that restricts the rest of this box. So the other ones that are missing are 1, 2, 3, 4, 5, 6, 7, 8 is already there, and then 9. So 1, 4, and 9 should fill these boxes. And out of those, we see that 9 is already restricting this. So we can take a note that it should be 9 in one of these two. 4 looks like it can be all 3 still. And 1 looks like it can also be all 3 still. But that's fine. We now know that 4, 1, and 9 must be in those. With 9 being only here. Yes, that makes sense. Alright, cool. So we have a pair. So the reason why I am only taking notes where there are 2 options is because I want pairs. I am looking for pairs because they are a lot of help. Okay, we've gone through 1 to 9. Let's start going back down through 8. So looking at 8 again, see if there is anything new since the last time. I don't see... Oh, here's something, maybe I missed it earlier. So we have 8 and 8 here. Restricts the 8 in this box to be only there or there. And now these are on a line, so we can use it to triangulate and see that we only have 8s here as well. 8, 8, 8, 8. That's nice. But it doesn't give us any further information yet. Okay, moving down to 7. 7. Yeah. Well, okay, there's this. So we have a 7 here and a 7, 2 7s on a line here. So it means that we can triangulate and see that this must be 7 or 7. That helps. Okay, moving down to 6. Doesn't seem to be much new here. There's only these ones which are unknown. And they are coupled in the sense that once one of them is determined, the other one will of course be determined too. Maybe I should call them entangled. 5. Oh, this is nice. So from this and this together, we have that these 2 options are the only ones for 5 here. And you can see from the fact that these are now on a line that we can get rid of, we can actually resolve the pair that we had made down here. So we know that the 5 has to go over here, which means that this one is an 8. You see that this in fact gives us immediately the 8 up here for free. That's very nice. Which means that we can also conclude that 8 must be up here among these 2. So now we come to another nice situation with pairs, because now you see that we have a 3-8 pair and a 3-8 pair, and there aren't any 3s or 8s anywhere else. So we know that 7 can't be there because it's a 3-8 pair, and therefore the other option for 7 must be the one that is correct. Okay, we have some new information regarding 7 here. We can triangulate and use it to conclude that we have 2 options for 7 up here as well. Now, because this box is getting a bit crowded, I am tempted to see what else is missing. So 1, 2, 3, 4. Yes, we know that because of this, we know that 4 must be here or here. So let's take a note of that. 5, 5, 5. We know that 5 must be in one of these 3 places. But since it's 3 options, I'm not gonna take a note of it. 6, 7, 8, and 9. So what's interesting about the 9 is that 7 is in one of those 2 places, 4 is in one of those 2 places, and 5 is in one of those 3 places. You could call it a triple if you want. You have a 4, 7, 5 triple. Which means that the only thing that can really fit in here is the 9. So now I didn't use triangulation, I instead used a process of elimination. No other number could be there, so it had to be a 9. Now what's nice about this is that you can see that the 9 has to be in the middle box from these facts here. And with the new 9 in the middle, we know that it is actually either the top or the bottom. And we get a new pair, a new 5, 9 pair. And since we only have 4 boxes free here, and one of them is a pair, the other one must also be a pair. So the other option which is missing in this box is 1. So we have to have a 1, 4 pair here. And this one we can immediately resolve because we see that there is already a 1 here. So therefore this has to be a 4 and this has to be a 1. Alright, that feels like progress. This box is getting crowded. Let's take a look at what is there and what is missing. Well, first of all, this box up here is also missing a 1, I can see. And we just got a 1 here, so it means it can't be there. So that means that we get a 1, 7 pair here to the left. And since there's only 3 boxes free, that means that whatever is not taken into account yet has to be there. So that's 1, 2, 3 seems to be the final number. Oops, not a note, but an actual number. There we go. And now we see that this seems to have resolved some options for us to the right, so we can make this be 3 as well. And then to the very left we get 3, 3, so it must be on the bottom here, and then this one restricts it further, so it's worth taking a note that we have a 3 and a 3. Okay, so we have 6, 7, 3, but it's still not any pairs, so it looks a bit messy, but it'll just have to stay as it is. Okay, but I was wanting to look at this down here. So we can see from this row that all of them are filled in except for 2. So this must actually be a pair that I just haven't figured out yet. And the other number that is missing is indeed 1. So this must be a 1, 1 pair. I mean a 1, 9 pair. And you could also see this from the fact that we have 1 on a row here, 1 there, and you can triangulate to find 1 there. Once again, we have a pair and we have an open box, so whatever is not taken into account must be in there. So that's 1, 2, 3, 4. 4 goes there. Okay, does that give us anything new? Well, it means that 4 must be up here somewhere. So we get a, and this one restricts it more, so we get a 4, 4 pair here. And then I noticed that here a note seems to have gone away, so maybe I didn't notice it earlier, but I guess when I put in this 4 up here, it removed the 4 that was there. So now we only have 4 here as an option, so I put that in, which means that I can put the 4 here. Okay, that's nice. And similarly to the left, we have 2 options for 4, 4. Okay, let's see what is missing in these boxes. I'll start with the rightmost one. So we still are missing a 1 that can be in either of these 3 places. I'm not going to make a note of that. 2, 3, 4, 5. I've already taken a note of 5. 6, 7, 8. And finally 9. And 9 can be in all these 3 places. Okay, so I'm not going to take any further notes yet. To the left we have 1. Seems that 1 can be everywhere for now. 2, 3, 4, 5, 6, 7, 8, and then 9. Do we know anything about the 9? Very little, it seems. Okay, so the 9 can still be anywhere, essentially. Alright, so it was a blind alley. Here we have a pair, because there are only 2 boxes left, so let's figure out what the other one is. 1, 2, 3, 4, 5. That must be 5. 6, 7, 8, 9. Okay, so now we have 5 on a line here, which means that we can resolve this pair. So this must be a 5, and this must be a 9. There, we completed our box. Isn't that nice? So let's see if that gives us any leeway to the left here. Let's start. So the 5 was already there actually, so that doesn't help us too much. This one, I mean. And the 9, 9. So we know that the 9 must be on the bottom here, but we don't know anything else really. So that's still not so helpful. Okay, from top to bottom it's 1, 7, and both of those are still good. Okay, let's go somewhere I haven't been in a while. So top right, for instance. Let's see, the 1 we can't really restrict too much. It's in one of these 3 places. 2, 3, 4, 5, 6, 7. Also in one of these 3 places. 8 in one of those 2 places. And 9. Well, the 9 we can actually resolve thanks to these 2. So we know that 9 has to be here. Now this helps us, of course, resolve the 9 down here. 9, 9, 9. Which gives us the 8 here. Now that we only have 2 left open, the other option... Oh, god damn it, I hate it when that happens. 5, 1, 5, 1. Okay, so now I learned that 1 is not supposed to be there, but I will pretend that I didn't see this. Regardless, we know that 1 is on a line. So, yeah, this actually becomes easy to resolve now. Right, because the only other missing number from this line, apart from 1 and 5, is exactly 9. And then this one must be 1. So that's helpful. Okay, let's continue. So we're missing a 1 in this box. And we have 1 on a line here and 1 here, so then the 1 must be here. Which means that we only have 1 other option here, which should be a 1, 2, 3, 4, 5, 6, 7, 8, 9. Notes on. Okay, 4, 9, 4, 9. So it feels like we're getting somewhere, slowly but surely. As you have probably noticed, I mostly look at boxes and very rarely at actual lines. So sometimes it's good to, you know, lift your eyes for a bit and look at the lines. And similarly for the line, we have a 1-7 pair here, a 3-8 pair, and a 5-7 pair. Oh, here we have a line that I have not completed, so let's do that. 1, 2, 3, 4, I guess. I could also do as I usually do here and triangulate it, but it's nice to, with a change of perspective. Oh, and How did I miss this? Huh, okay. You probably saw it before I did, but of course the 4 can't be there, so this is not a pair at all, this is just 9 and 4. Okay, we got an ad. I hate that fucking king. Every single ad, it's the same guy. Let him burn. Okay. So let's continue to work on the middle left box here. So we can triangulate that the 1 has to be in the bottom, but it can't be in the middle row, so it has to be here or here. So 1, 2, 3. Oh, we now know. Oh, did we already know? Did I miss that earlier? You probably saw that one as well. Okay, so 3 can't be there, so it means that 3 has to be here, and 8 has to be there. So we have a 1, 6, and what's the third option? 1, 2, 3, 4, 5, 6, 7, 8, 9, of course. So this is nice, because now we see that due to this 9, the 9 also has to be there and there, and we have made ourselves a new pair, 1, 9, 1, 9, with no other options for either the 1 or 9 number. So it means that the 6 can't be there, it has to be here. From this, we can see that we can now triangulate the 6 in the top left. Sorry. 666, number of the beast. Let's see, is there anything I can do in the top left? The 1 here is in one of those places. 2, oh, 3. There seems to be only one option for 3. And indeed, we can fully triangulate it and see that this must be 3. And due to my notes, it seems that this has to be 7 in that case. 7, 7, 7. Yes, that checks out. Oh, it was also a complete line. I didn't notice. And similarly, I can see from my notes that this means that this must be an 8. And you can double check this. So now we only have 2 more options here, so let's find out what they are. They are 1. I can actually see from this one that it has to be 1 or 9. 1, 9. And then the other one has to be the same. 1, 9. So let's check that I haven't written anything that can already be resolved. 1, 9, 1, 9. No, both seem to be viable options at the moment. But what we can also see is that since 1 is on top or bottom row, both here and here, it has to be in the middle row on the third box. So let's put out 1, 1 there. And then I also noticed that here there seems to be only 1 8. So that probably means that there were 2 8s, but one of the 8 notes went away. So indeed it seems that we can fully triangulate this to be an 8 now. New add, of course. Fuck off, king. Bye. 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 And where were we? Yes, so this one has to be a 1. The final one of this row, actually. 1. So now this box is only missing one thing, which would be a 7, it looks like. And that means that this has to be a 7. Triangulate it down here. And the final one is 1 up here. Which means that this is a 1 and this is a 9. So the nice thing about taking a lot of notes is that since they disappear automatically in this version of the game, at some point it just becomes a sort of paint by numbers. Just find a square with no other options in it and just put in the number. And we are done. Wasn't that nice? So yes, in conclusion, I would say that the seeking out these pairs is like the main technique to solve hard level exercises. And then as you go to expert level exercises, you might need more complicated techniques. So of course you can do the same thing with triples that I've done with only pairs now, but it very quickly becomes a lot of notes and a lot of numbers to keep track of, which is why I like to stick with pairs as much as possible. Alright, thanks for watching, and don't forget to like and subscribe, and leave a comment in the doobly-doo. Goodbye.